thank you very much. That's a great welcome. Thank you very much. I never actually realised we'd be the first. You didn't tell us that. That's quite an honour. Let's get myself sorted. Tell me when you can see the screen.
Yes, we can. Yeah.
We are. Splendid. Getting there. Okay, Phil, after you.
Okay, so thank you very much for joining us. Good evening, everyone, and thank you, Philippos, for that glowing introduction, and congratulations on all the work that's going on in the UK chapter for ASHRAE. So, Ian, if you just, as you're driving, I'll give you a prompt for each slide. So we're going to talk to you today about what's happening in the sector of data centres and ICT. Then we'll look at environmental impacts, sustainable solutions, and decarbonisation, with some time at the end for Q&A. But as Philippos mentioned, we may well stop after each section and ask if you have any questions, so that there's sort of you have a more recent memory of what the question was. So next slide, please, Ian. So today we're going to introduce to you, just go back one, sorry, to introduction. If we're going to introduce to you basically to try and give you some visibility on the industry of data centers, which is a huge industry and growing very, very quickly. We haven't got the glamour maybe of aerospace or Formula One cars, but in terms of growth, in terms of innovation that's being pushed on us, I think we exceed any industry. It's quite stunning as to what's been happening in the industry in the last 5 years. And that comes with a lot of challenges. It comes with challenges in terms of resourcing it. It comes with challenges in terms of bringing new innovation to market very quickly. And of course, it brings challenges in terms of the effects we have on the environment, on climate change and all the emissions. So as engineers, it's forcing us to become very, very creative, which is wonderful. And we are very much being held as as being the leader in driving this technology forward. There's a saying that says that innovation is driven by diversity of thought, but there's also another saying that necessity is the mother of invention. As you'll see later, there's a huge pressure to increase IT, to service the internet, to service all the devices that we're using, big data, artificial intelligence, the Internet of Things. All of these things demand a huge amount of support in the infrastructure, and data centers are the hidden buildings behind that. If you ever want to see what a data center looks like, it's incredibly and quite purposely anonymous. So if you go to a trading estate and you see a building with no signs outside, barbed wire, and a few sheds put together, the chances are it will be a data center. But they, for obvious reasons, they remain very anonymous. What we're here to do is to serve the demands of the markets, and also very much at the same time to mitigate the effects on climate change. Next, please, Ian. So a little bit about our company. So we're part of the ENGIE Group. ENGIE is a large French organization, a global organization employing around 98,000 employees worldwide, and turning over at the moment around 67 billion euros a year. They invest and they operate and they design and they maintain low zero carbon energy and other utilities for the facilities. So they're very much, their motto is the 4 Ds. That's decentralization, digitalization, demand side reduction, and decarbonisation. So they are really quite serious about investing in a zero carbon roadmap within the next 15, 20 years. And at the moment, they've invested so far into just over 34 gigawatts of renewable energy generation capacity, which then connects to around 23 gigawatts of distributed energy and infrastructures. So they both produce the renewable energy, the zero carbon energy, and they distribute it to point of use. At the moment, they have just over 1.4 gigawatts of PPAs, which they deliver purely to the data center industry. And apart from that, they have other PPAs for other industries, which means in reality, they will build, for example, a solar farm or a wind farm somewhere else, and that will become a real investment into injecting zero carbon into the network, which is then sold on as a power purchase agreement. So it's not just pieces of paper, it's real action in terms of delivering. And so far, they have 4 gigawatts of green hydrogen capacity. That's manufacturing of green hydrogen from 100% renewable energy sources. RED itself is 100% part of ENGIE, and we've been going since 2004. We doubled in size during COVID, which shows you what happened to the internet industry during the lockdown. And right now we have about 750 employees distributed between Europe, the Middle East and the Far East. And right now we're turning over 80 million euros per year, and that is growing quite considerably by the year. So we have to almost hold back on the acceleration at the moment, such as the demand for our expertise. We employ presently 17 tier designers worldwide. So this is the Uptime Institute tier, which is the way of actually providing a KPI for how resilient a data center is. So these are accredited tier experts that can actually assess how reliable mission critical buildings are designed and operated, and which tier level they reach. To date, we've completed over 800 commissions in terms of data centers delivered to the markets, and we cover data centers all the way from the real babies at 300 kilowatts all the way up to the giants at 480 megawatts. And that 480 megawatts is actually growing and is probably more like 600 megawatts at the moment. And that is purely the IT load, in other words, the amount of power that is absorbed by the IT equipment within a data center. Within in 2020 itself, we delivered 5 gigawatts of IT. So during lockdown, we delivered considerable amount of IT to the industry. Next, please. So what do we do? Well, we're engineers. Probably 85% of us are engineers that are producing projects, doing research and development, and actually overseeing projects, bringing data centers, but also other industries to the market, both from all the way from feasibility stage right up to commissioning and handover. We're generally for mission critical buildings, for technical based buildings such as data centers and pharmaceutical buildings, we're very often the lead designer. So we will lead the whole project, and we will employ architects, civil engineers, fire engineers, and acoustics specialists, and the such like. So we will be not just the designers, but the design team leaders also. High emphasis on sustainability, which Ian will cover later as well, and also a big involvement in the information communication technology sector, which is all part of what we do. Again, health and safety is huge. Our parent company makes sure that's the case, not just in terms of how we operate on sites, but in terms of how we design our systems to be fail-safe and to be safe to both to work on and also maintain. And process engineering is very much part of what we're doing. It's a new part of the industry, but power generation and decentralized power is something we'll talk about later, which leads us more into the process side of things as well. So that's what we do. And I'll now hand over to Ian for the next section.
Thanks, Phil. So I'll get straight into it. And I'm definitely one for question and answer. So please get your hand up as soon as you feel necessary. When you're talking about data centers, you have people that know what they're talking about, people that understand it, and people that read the press, and then people that don't even know that they are. There's a vast array of ideas about where your text messages go, where your WhatsApp goes, and to some people it's just exactly as it's described. It's the cloud. It's completely untangible. For others, they know the dirty details all the way down, and I'm sure in this audience there's probably a cross section. So apologies if we go a little bit too technical on two things. It's not intentional. It's kind of what we do every day. And then if you know very well, I apologize for dumbing it down. So hopefully somewhere in the middle we'll find a happy audience. Right. Basically, let's start with what is a data center. It's a big computer box. Essentially speaking, what we're talking about here is a facility designed to house servers. Now, servers are, if you forgive the parlance, if you look at the laptop in front of you, imagine several of those in a small rack. In fact, at 100, and you've got maybe something that looks like a, I don't know, 4-inch by 32-inch by about 2 or 3 feet box, and we stack those one after the other in lovely things called racks. Now, those racks are basically computers after computer after computer. There's the same technology that sits in most of your laptops. They are processors, ones and zeros, turning on and off, lots and lots, millions and millions, if not billions of switches in every single server. That sits in a nice box, which you can see here. either in, sorry, where's my mouse? Here we go. In the main IT spaces, and you sometimes have tenants that want different modular racks, so something that they perhaps design themselves, or else you'll have things like colos, which are co-location. So you have lots of different servers from lots of different companies, and companies that provide a service to actually house them. Ultimately, they are talking about where your IT systems sit. Now, obviously, there's a lot of power associated with them, and a lot of these are associated with governments, they're associated with emergency systems, they're associated with power systems. So you need to have a lot of backup power, and that is one of the defining factors or defining characteristics of a data center is uninterruptible power. So on all the time. And we'll get into it later on, but we talk about nines in 5 nines being availability. So your IT has to be available 99.999% of the time, and that's very hard. There's only 2 industries that really go any further, and in fact, they don't go too much further, and that is the safety around transportation, where you have basically mass human potential for loss if something goes wrong. In IT, it's actually getting to the same place because a lot of the control systems for transportation and other critical national infrastructure comes in IT, underneath the IT purview. So now we're getting into a stage where these buildings are very, very robust. Okay. What does it all look like? So this is a quite a modern arrangement with everything is top fed. What you see here are the empty racks. So this would be a data center waiting for the servers to be installed. Eventually, every single one of these will be filled with rack after rack, server after server sitting in these racks. Now, if I was to say that one of these racks, so one door that you see here, if you were to fill that with servers, that could be anything between 40 and 80,000 pounds worth of servers just in that one rack. And you can imagine this goes on for rack after rack after rack. And this would be a very, very small data center. This would be the 300 kilowatt kind of data center that Phil was referring to before. So when you get up to the 4 megawatts, now 400 megawatts, you can imagine the scale and the cost and the value of these items. Obviously, all that IT is going to require some cooling. For a long time, the data center industry was based in the hottest places on Earth. It started a lot of its life in America and in the hot states of America. And so the development of the actual early data centers was largely around how to cool them. And it still is to some degree. It's just that we're getting more and more intelligent about how we do that. These here are very, very large cooling towers. You also see these in the Middle East as district cooling. So it's very similar technology. And also you'll see that there is always more than one of them. Every single time there's module after module of data centers. Now that's because they have standbys. So if something goes wrong with one, another one can kick in and keep it moving. Also, the other end of it, if you're going to create heating, you need an energy source. An energy source generally comes from electricity. Well, it's always coming from electricity, and that is generated either off-site or, in this case, on-site. And what you see there is effectively a power station. What I used to describe this as many years ago was every single one of those boxes is equivalent to an Intercity 225, so a big old train running flat out. And you imagine that lined up one after the other. It's quite a thought of the scale of power we're talking about. Nowadays, that parlance doesn't work simply because they're too small. The engines you see in data centers now are much, much bigger than that. Thankfully, the majority of them sit and do nothing for 99.99% of the time. The only time they ever use them is when they're being tested. If they are using them and you do see them being used, it's usually because something's gone wrong in the grid or there's been a very large failure somewhere. So that is it's one of the challenges, as Phil said, in terms of how we can make these more sustainable. Luckily, it's not the biggest challenge, but standby power is something that we're going to be grappling with for a very long time. Okay. Let's get on to the actual why the data centers there in the first place. So in the past, information was doubling every century. That was really as we got into the digital age, but predating that, there was very little recorded information in comparison to where we are now. In 2022, we jumped from 2 zettabytes, and a zettabyte is 1 trillion bytes. It's a lot of information, but only a few years later, 3 years later, we were doubling it. So we were doubling our data every single year. Sorry, that's a bit of a prediction. I think we've actually gone past that already. And that's largely because of autonomous vehicles and things like that starting to create masses and masses of data necessarily for insurance or for safety. And things like AI is starting to write its own script. A lot of the script, we don't know why it's there, but it's critical to the functioning of AI. And AI is driving so many things we don't understand quite what it's driving in our infrastructure because it's everywhere. Trading, 98%, something like that now, is assisted by artificial intelligence. So next year, I think it's actually going to hit 100% almost because of regulations. But in the US last year, about 91% of all cars are actually connected up to the internet. And one of the reasons is regulations required for accidents and insurance companies, not to mention your radio stations, your Twitter, your Teslas feeding back charging information and all those lovely things. Obviously, if you're going to have something giving out information like a car, like your watch, like your phone, you need the grids and the infrastructure to actually understand that information. And there is a network going from every single device that connects to the internet through various modes back to these data centers. And they are the smart cities, the microgrids, and all the electrical information between what you're looking at right now, where the data center is, and then back to you again in a constant cycle. That's not to mention smart buildings themselves. So I think when we talk about sustainability, we quite often talk about metering and sensing and having automatic systems. All of that relies on the internet. Every single thing you see being smart generally is talking to the cloud and giving the data upwards and downwards so there can be automated control. As I just said before, watches, and not just watches, things like the tags on your luggage or ESG machines you see in a lot of clothing now are there increasingly, and they are going to be monitoring, especially in things like PPE, how people are, their temperature, their pulse, and they can notice if anyone's having a slip or a fall or an accident. And you're going to see that more in the older generation in the healthcare industry, and that is going to drive a lot of the technology, the human scale technology. Now, the big one that drives a lot of the redundancy is data sovereignty. This is literally, can I get money out of the bank? All the way down to, is that dollar, is that pound, is that euro secure? Is it free from the influence of a foreign power trying to devalue it? And there's where data sovereignty actually creates the need for very, very secure data protection and the infrastructure that we're talking about. And you also have networks of this data. So it's not only held in one place, it's backed up in other places. So you may have the requirement for one data center, which has 100% backup. And then the same data center will be matched elsewhere so that if that data center was ever to have a catastrophic failure, the other one would be there as a backup. And that is increasingly happening in every single country. The threats against the World Wide Web are daily, and the amount of infrastructure to combat that is growing very, very quickly. Okay. Environmental impact. I guess you've probably seen a few programs in the press about this. There was one in the BBC very recently. Ironically, these are all coming to you through iPlayer or similar online devices. I certainly watch a lot of my TV through a telephone, maybe on the train and things like that. So the irony of watching programs about data centers through data centers is not lost on me. And I think one of my favorite images was of a campaigner for water usage in Arizona, doing it all on Twitter. And she was outside a data center which was handling Twitter. So it's an interesting web of how the environmental impact is integrated with what we do, and yet we're still battling against it. So in terms of hyperscale, the kind of where all this data goes is driven by cash. It's driven by you and I paying for our services, paying for our mobile phones, paying for data. And the numbers are massive. They're absolutely massive. 124 billion across the world, spread generally where the spending is. So that's America and Europe is obviously leading. Asia's massive. So per head, it's slightly lower, but it's there's a lot of hotspots there which are growing very quickly. And they're also very fast adopters. The whole of the world is actually growing very, very quickly. And it is seen, the internet is generally seen as a leveler across the world. And there you go. The global market is not 124. I apologize. It's 212, and it will be growing, and it will continue to grow very, very quickly. The curve is not exponential as such, but it was a couple of years ago. It does fluctuate depending on where the markets are. There's also the demand for data is pretty exponential, but the ability to satisfy it is also incredible. So the two things don't necessarily tally. Okay, so the actual amount of data consumed there is 200 terawatt hours. That's don't quite know how to explain that number to you, but it is very, very large, and unfortunately, that requires an awful lot of energy and creates an awful lot of carbon. In fact, it's about 8% of the UK, sorry, not the UK, the world's carbon, and about 1.1 to 2% of the demand for electricity worldwide. There you go. There's the kind of growth we're experiencing in internet traffic. Not quite exponential yet, but getting there. So, sorry, I'd said 8%. I'm looking at two graphs at the same time. Do you know what? There is a number of conversations out there about how much the internet is actually using and how much the device that you're looking at is using and whether the two are connected. But we did a study for a very large video provider, let's say, a media company, and they were grappling with the fact of what is they're responsible for and what you're responsible for. And that is why we have this range of 3.2 up to 6.2, and some reports up to 8% of where that electricity is being used and how it is being used. But ultimately, it is all associated with the internet. So the growth that you see in the graph on the right-hand side is going to lead to even more use. And ultimately, I mean, I'm sitting here with two telephones. I have a laptop in front of me. I have an Alexa to my side. Where does it stop? Where are we going to stop actually connecting to the internet? It's an enormous number of devices that continually added. Because of that, the industry is growing quickly. Okay. So, Phil, this is over to you.
Okay, thanks, Ian. So just to talk before I go into this, what the drivers are to the market, it's just to talk a little bit about the wastage in terms of how much energy gets wasted in a data center, and that's to do with underutilization of existing assets. So very often you'll have utilization of servers, for example, running at just 20% capacity, or in the case of Windows servers, 90% capacity, well below their normal maximum operating capacity, but still running at 30 to 60% of their maximum power. So this is the message here is, and as Ian mentioned, every time you do a 1 or a 0 in a digital calculation, that's using power, and very often that power is just going nowhere except into heat. So this is something that's really of concern. And at the moment, the market is very much driving towards making the management of where the data processing is done, where the data storage is done, as a priority as well. So this moves us on to this slide now, which really speaks more about the what are the drivers. So from what I just said, obviously the management of the data is really important. But what's pushing the market a lot is, and in no particular order, is regulation, first of all. So that could be global regulation in terms of the EU Green Deal, or the Green Data Center Pact, which is targeting zero carbon data centers in the next 15 years. But usually at the moment, and what we're really feeling right now, is regulations and planning and authorization to build from local authorities. So that could be city scale, it could be regional scale, and they're imposing some fairly punitive restrictions on how we build these data centers to make sure that we're actually minimizing the impact on the environment and have a clear roadmap to zero carbon as well. So that's one of the main drivers right now. The networks are a huge driver also. So many of the networks we're trying to connect to right now don't want any further load on their networks. They're being saturated already. So you've got places like Ireland, for example, where there's a huge drive to increase the IT capability and build more data centers. But the grid is pretty well saturated in terms of generation and distribution. So they have a huge problem there. And going back to what Ian was saying earlier, it does mean now that we're not looking not just to build a data center, we're looking also to build a power and cooling generation center at the same time as part of the same project. A lot of it comes down to business sense. So data center operators are trying to minimize their cost. The investors in those data centers are also trying to get a good return on their investments, and therefore keeping operating costs to a minimum is very important. And those operating costs could be due to fuel, could be due to electricity, and it also could be due to the cost for maintaining and any carbon taxes as well. So these are all reasons to push us towards that green future. And increasingly customer pressure, which I've got noted here, and that really means the sort of altruistic type of ambitions that some of our customers have. They seriously want to get to zero carbon in the next 15 years, not just by greenwash, not just by buying PPAs, but actually investing in engineering systems that will ultimately allow them to run data centers which have a zero effect on the environment. Next slide, Ian.
You got that, Phil?
Oh, sorry, had that done to me. Okay. All right.
No, sorry, you're right. I was going to take this one. I was a slide behind. So one of the defining factors or defining characteristics of data centers, and this is borne by the relatively small number of very large American companies that are involved in the industry, is their non-disclosure, the secretive nature. They are very large industries and they have a lot of cutting edge technology. So in order to protect their business interests, they are quite secretive. Now, what that unfortunately means is that you very often can't find conclusive data because it's not in the public domain. So there's an institute in America called the Uptime Institute who recognize this, and they every year put out a number of surveys which data center operators, consultants, and anyone in the sector generally responds to. And this is a great way of looking under the cover, behind the curtain, as it were, to see what people are thinking is going on in the industry. And so part of these surveys is here on the slides. On the left-hand side was a great question of simply, in the next 5 years, do you think data centers in your region will be required to publicly report environmental sustainability metrics? And I find it very interesting that Asia, more than anyone else, think that yes, they will. Now that's a great. I think that's really positive for Asia anyway, and it's quite a slant against the North America there to say that they're going to expect it, because usually when these expectations come through, it's because they are the seed of the market sentiment, and that is what follows. The UK and Europe are most certainly expecting it because, well, we can see it coming. It's not there's no hiding behind it. People are signing up before it comes. They're talking about it before it comes, and we are involved with the writing of the next set of regulations, which data centers are very likely to have to comply with. So that's positive, I believe, for the majority of Asia and Europe, with everyone else following on behind. So on the right-hand side is another interesting slide where we were looking at, or Uptime was looking at, in your opinion, which of the following have the biggest impact in making data center industry more environmentally sustainable in the next 3 to 5 years? I'll start with the significant increase in energy prices. This survey probably predates the real bite of energy increases recently, and I suspect that would be much higher if that survey was to be taken today. Certainly in UK and Europe, and most definitely in Germany, you would find an enormously driver in the data center industry to reduce their energy costs in any way they can. And obviously that has an influence on the two largest portions of this pie chart, the 21% of improved data center cooling and the 21% of renewable energy purchases. Together, those three items are probably very, very interlinked and have the biggest impact on the carbon footprint of a data center's operation. The one which is underrepresented here, I think, is the more efficient chip technology, because ultimately what you are talking about is IT. The data centers react to what those servers want, be they one server or 100,000 servers sitting in an enormous data center. The chip technology is actually dictating how we design these, the temperatures they need to be at, the power supply they need to have, and also the refresh rate. So how many times do we change that server every year? Or sorry, how often do we change it in its lifetime? It's usually 3 to 5 years, depending on the technology, but it can be much longer if they're refurbished quickly. Or sometimes it's shorter when you have technology revolutions. If we move from air cooling to water cooling, for example, you will see a corresponding change in chip manufacturers and then the server manufacturers. So what are the metrics for change? If you take the history of data centers, it's always been about servicing the IT. The IT has been sacrosanct, it's been the 100%, and anything else you have is beyond that. And what we describe that is PUE, the power use effectiveness. That was always about cooling the IT down and nothing else. Nothing to do with saving that energy or recycling energy. It's purely how do we cool the computers down to keep them running. And that's worked us quite well in the last few years. Let's say since 2000, we've come down from a PUE of about 2 to closer to where we are now, which is 1.1, 1.2, depending where you are in the world. That obviously misses out on a lot of energy. And in the sustainable world, we need to look closer and closer, more iteratively, at how we get the most out of every single kilowatt of hour we produce, no matter whether it's fossil fuels or not. Eventually, we want to have them 100% non-fossil fuels, but we still need to be efficient with that to make sure that we're keeping our embodied carbon down as well. And that's where you have the renewable energy factor, bringing in other energy and making sure that it's being applied directly. The energy reuse factor, which we'll talk certainly later on about how we recycle the waste heat. The cooling efficiency ratio, a little bit technical on, but how you manage to reduce your cooling load. The carbon use effectiveness, which really is that should be the last one on this list. It is the ultimate goal. If we're going to have net zero carbon data centers, that is a combination of the embodied carbon and the carbon in use. So the closer we get to zero on the embodied carbon, the closer the CUE will be if we buy 100% renewable energy. That 100% renewable energy, we also have to understand, is it really zero carbon? It may be being produced by solar panels and wind, but ultimately those solar panels also have a carbon footprint, and we need to understand the totality of it. So the carbon use effectiveness will become, I believe, the real tool for us to measure and be the metric for the future. The other one, which is integrated into CUE and PUE in certain parts of the world, is the water in use. Now, that water in use is it's got a social side. It's a very, very strong social aspect to it as well, because denial of water in any part of the world can have catastrophic effects and needs to be heavily monitored. So it has not only a social cost, but obviously a carbon cost as well. So the other metrics that we have metrics, you need to be able to measure them accurately. And ASHRAE, thankfully, have a 90.1 and a 90.4 standard. And they really are the best standards we have in the industry. And some of them are very, very strict and very hard. We're doing a number of them now, and we have done historically. And to really measure up, ASHRAE do provide the best calculation tools for compliance. There's obviously more reference on that in the ASHRAE 90.4 memo, which you're more than welcome to follow that link to when this is circulated. Just before we move on there, I saw a couple of questions in the chat.
Keith has asked about data center heat rejection, and actually, Keith, there is a slide about that later on, so if you don't mind, we'll just delay the answer to that till we get there, please.
So the WEE is water in use. So that's the how many liters of water you need to create 1 kilowatt hour of cooling. That's the short version of it. It becomes much more complicated when you look at water in power generation as well. But and we don't go into too much detail of that. We could have a whole presentation just on that. But if you consider it just how much water a data center uses, it's a fair description. Okay, so I'll move on to sustainable solutions, or else we're going to run out of time slightly. Okay, So data centers, the drivers for progress, what achievements have we made? So data centers didn't really exist until the 1980s. And even then they were just computer rooms. And then they moved on to effectively taking over the telecoms industry. And at that point, they became what we think of as data centers now. So we're talking about between 1980 and 2000 was the transition there. And in 2000, that's when you could really say, yes, that is a data center, similar to what you see now. And in that time, we've come from a PUE, power use effectiveness of about 2. So that's 2 kilowatts of power, creating 1 kilowatt of usable electronic calculating. So that's computing power, as it were. We've come down to about 1.2. Now it does vary across the world, but that's currently the state-of-the-art global average. And certainly some of the larger hyperscale data center guys aim considerably lower than that. It's a scale where you have diminishing returns. It's much easier to get from 2 down to 1.5 than it is to get from 1.5 down to 1.2. Every time you try and get closer, it's exponentially more expensive and technically harder to do so. The simplest thing to do is go somewhere cooler. And that's where you see a lot of data centers being built in the colder climates. So energy waste due to hotspots. Something that has occurred from the natural progression of Moore's law, getting computers quicker and quicker as we're able to do more and more accurate calculations. Putting in data centers and modeling them in with CFD allow us to look at every single server in this location in a data center and work out how much cooling that data center, that specific server is looking for. And then we can move them around. We can actually manipulate the cooling systems, ventilation systems, so that we are minimizing hotspots and dealing with them quickly. And that means as a server moves through its cycle in a day, where, for example, if it's in the UK, it's going to be more heavily loaded in the morning when people are logging on, and lightly loaded at midnight, where people are backing things up. And you see the data center have waves of heat being dealt with differently by the cooling systems. Excessive cooling demand, energy demand. So this is optimization. What we're talking about is taking a data center, really looking at how we can control its internal environment by best using its external environment. A lot of the best technologies now rely very little on water and try and use free cooling wherever possible. And that is basically trying to to get synergy with the external environment, the maximum use of heat rejection into the environment. The other one that's happened, I guess more in the last 10 years than any other time, is we've realized that computers can run very hot. They can run much, much higher temperatures than was traditionally thought. A lot of people think a data center is a cold place, but now the most modern data centers have much higher temperatures, and they're running at an inlet temperature of 27 degrees and outlet temperature much, much higher. So the building up of that temperature, they're allowing that temperature to rise, means you get a better delta T with the external environment, and you reduce your energy use. Density. So incorporation of dedicated high density servers means that we can really cut down on the amount of space we're using, which ultimately is more efficient for energy distribution, cooling, etc., etc. And the more compact we get, the more dense the energy is going to be, and the better we can control it. And then we're looking at the installation of high efficiency ventilation and cooling. That's happened across the building services sector, as you well know. It's the efficiency of motors, it's the efficiency of fans, and it's getting better and better. So every time you see a new fan come out, at some point, there's probably been someone in the data center industry that's pushed its design or funded its design. Some of the DC motors originated from the need to bring power loads or computer room air conditioning units down in energy use and up in efficiency.
Ian, just a time check. We've got 12 minutes.
I am getting too technical, aren't I? Right. Then, as Phil was mentioning, servers utilization, virtualization of servers is creating a massive ability to double the amount of servers you have without actually doubling the servers. Moving on, it's the latest generation of backup power. So this is technology getting faster and faster in terms of battery technology and other surrounding electrical infrastructure. Things like high efficiency switchgear and transformers. The other one is control. Ironically, a lot of the data center demand is about how we control everything around us, and it's the BMS controls, which are in every single building, usually rely on a data center, and that technology is driving even greater efficiency in our own data centers. Okay. So this is really what we were talking about a minute ago with the CFD. These are the kind of tools we use to get more and more efficiency. It's modeling. There's no two ways about it. We model the hell out of data centers. We're doing a lot of design based on the air movements, based on how every single item in a data center works. That's electrical, mechanical, passive and active systems. I'm going to skip these or else we're going to run out of time. So if you see anything interesting, shouts. This is the playbook. This is the playbook for how you create a modern data center. You're starting with the ventilation, looking at how the cooling works, controlling it very well, metering it and verifying it. And that's increasingly important for actually proving to your customers that you are operating at efficient levels. Making sure your internal temperatures are high, and then making sure your IT is working very hard as well. So the current approach to decarbonisation, you probably noticed a few of these before. LEED is still probably the best standard in terms of certification for data centres. BREEAM lags behind. Its standard is about 15 years old. There's many drafts. There have been many drafts of its replacement, but we've not seen it come through yet. We'll also see, certainly for the offices, neighbours will be coming in, but not for the IT load. We don't think that's going to happen yet. And then it's the actual customers, sorry, not the customers, the people that work there are increasingly asking for better conditions. So you're actually looking at the whole of the data center being thought of as a place where it can assist the community and hence you get well added in. The big one in here, though, is embodied carbon. And that's an adventure we're just starting as a sector, and we'll be driving very quickly towards it. There's a number of drivers towards having net zero embodied carbon as well as net zero end use data centers. Great. Now, as we mentioned before, the more dense you have, the density increases, the embodied carbon comes down. Also, the quality of the heat rejected goes up. And now, one thing about data centers is that we have for very, very many years talked about how we can reuse the heat that we create. And the problem's always been, it's been quite low temperature, let's say 40s at best. If we go to liquid cooling, or when we go to liquid cooling, we're likely to see that temperature become much more attractive to district heating, which Phil will address later. But that's certainly where the industry thinks it's going to go, and I believe there's a lot of money behind that. We're already seeing them come up in various places. Bill.
Okay, thanks. So we're going to have a look at, very briefly, I won't run through the text you'll be relieved to hear, but just a brief overview of the technologies we're looking as they come to market. So fuel cells is one of them. I'm looking at fuel cells from 2 points of view, either as a primary energy source or as a secondary backup energy source, working together with batteries. Different technologies for different uses. So the one we would use for backup, which has got a very fast ramp up rate, would be the proton exchange membrane type of fuel cell. And the one which is takes a long time to wind up, but it could be a primary zero carbon fuel source in the future, is a solid oxide fuel cell, which has been, and different manufacturers are developing different technologies that they're very different in their characteristics. So the fuel cells can run initially off natural gas and then be converted to biogas or to hydrogen later on. We're not sure if they're going to be mainstream. They're sort of being developed and introduced at pilot scale, but we remain sitting on the fence as to whether they're actually going to become part of the data center long term. My personal feeling is they won't. There are certain things against them. They are very high efficiency. They are very green if they're being fed by hydrogen. However, they're also quite expensive and they take a lot of space up. And you've always got the problem of where do you store the gas? That if you get a gas shutdown, for example, if you're running off natural gas, where are you going to store the gas? Where are you going to store the hydrogen? So fuel cells for me are something that we are still considering. They're a green technology, but I'm not entirely convinced that they will be part of the picture moving forward long term. Next, please, Ian. Multi-fuel engines, at the moment, we're using diesel gensets. HVO, hydrogenated vegetable oil, is being introduced as a fuel instead of diesel, which is has a much better, much lower environmental impact. However, those multi-fuel engines moving forward can be quite difficult when it comes to a gas engine or a diesel engine, because to convert them, you have quite a lot of work to do on them in terms of retro-engineering. So some manufacturers are actually developing engines that will run proportionally on a certain proportion of hydrogen at the moment. However, to switch from one fuel to the other is very difficult, and therefore we're looking more towards gas turbines, as the way forward, because they're much more flexible in terms of the fuel they use, and you can use dual fuel burners, and these will be used more as a primary power source. So diesel generators will have to be phased out one way or the other, and we're looking at the different alternatives in terms of engines as to how we do that. Next, please, Ian. Energy storage is key as well. So it could be very short-term energy storage. When you get a sudden power outage, you might for a few seconds need full backup, and that will come in the source as battery energy storage. But battery energy obviously is very restricted in the amount of energy it can store. You may then rely on diesel backup gensets or gas engines in the future, or fuel cells as well, to give you that medium-term backup as well. But you still need to have enough fuel storage on site for 48 or 72 hours storage to run that data center. So it's a big ask, and as you can imagine, there's a lot of work going on in that field as well, looking at things like flow batteries, flywheels, and engines and thermal storage. Both there's very, very short-term and longer-term backup. Next, please. So waste heat export, just going back to Keith's point, waste heat is becoming very, very important now in terms of how we design our data centers. All the electricity that goes in, or nearly all the electricity that goes into a data center, comes out as heat. At the moment, that's being chucked up into the atmosphere, and it makes huge sense to capture that heat. Even if that heat is very low grade, could be around 26, 27 degrees, it is still energy, and it can still be upgraded using heat pumps. So to go back to Keith's point, we're coming across some regions, some municipalities that will insist that data centers have the ability to export heat in the future, and normally donate that heat free of charge to serve local residential or industrial or commercial developments nearby. So it's being driven a lot by local authorities, and it's politically, it's obviously very, very desirable to do that as well. So low temperature heat loops, very, very important to incorporate within data center design moving forward. Next, please. There's a big one, so just click a couple of times, please, Ian. I won't go through all this text. Just come to the end here. Just to give you an idea, a 100 megawatt data center in the middle of summer in the UK will be using normally about 15 litres per second of water in terms of evaporative cooling in the cooling towers. So if you look at a 15 megawatt data center, that means it's using about 130 million gallons a year, which is about 600,000 million litres a year of water. And even in Ireland, would you believe, where it's considered to be quite a wet country, they're running out of water because these data centers are taking so much. So it's becoming a huge problem. We need to use less water in how we cool our data centers. We need to recycle water, and we need to capture it using rainwater harvesting. So water is an incredibly important part of the whole picture as well. Next, please, Ian. And moving forward, so over to you again, Ian, on this one.
Yeah, we're running out of time rapidly here, guys, and apologies for this. What I was going to cover was simply the ideas behind how we get to net zero. It can be broken down into two very simple topics. It's lowering emissions, obviously, into the atmosphere is how we create power. And the second one is by removing gas emissions from the atmosphere, which are capturing carbon. Now, we've broken it down in those two in our company as the two main challenges we have: capturing carbon and having 100% recyclable buildings. Because where we say lowering emissions into the atmosphere, it's not about power anymore, because as you can see from these wind turbines, there are ways and means, and we believe we're on the track to having 100% renewable grids at some point in the future. And the technology is there, so we've cracked that technology. We need to get the businesses behind it. But what does remain is the embodied carbon, and that is a very large number. It's not just our sector, it's every sector. But the only true solution is to have 100% recyclable buildings. And there we go. This is how we do it. So, operational energy, as we said, the biggest customer in the world for renewable energy is the data center industry, and they are funding for more of it. Once we get into things like liquid cooling and things like very high utilization servers, we will have a lot of very dense cooling requirements, and that will bring down the significant amount of energy use. On-site renewables, don't think of putting PVs on the roofs. That's not on-site renewables. What it's more likely to be is you find a wind farm and you'll find a data center next to it. You find a nuclear power station, there'll be a data center next to it. It's having the power source as close as possible to reduce the emissions losses and to maximize the potential for the data centers backup to be used by a community or a microgrid. Data disclosure is an interesting one. We need to be able to share the data from every success in the industry and cross-pollinate it across the world, and that's absolutely key. It's happening more online in forums between peer groups than it is between companies, but it's certainly the successes of the large companies are very happy to shout about and very happy to share. And that is something they also push down into their supply chains as well. What we haven't got yet is a real integration between communities. There are several examples we've been trying and testing. Engie have a great one where they've been feeding waste heat into polytunnels and agro-farming, and hopefully creating a cyclical environment for the energy at very least. And then ultimately the end of life. So recyclable materials, and as I said before, 100% recyclable buildings is the main target. I'm not going to cover this slide. This is the embodied carbon I just discussed earlier, but we're happy to have any conversations. We believe we are leading the industry certainly in data center embodied carbon. Bill, I've given you about 4 seconds. Go for it.
That's fine. I think moving on, and when I say moving on, it's happening at the moment. It raises the whole prospect of the microgrid, of the decentralized and low and zero carbon on-site generation, whereby the data center becomes what we call a prosumer. So it's a producer, which benefits the local community and the local network, and it's also a consumer as well. So within the whole bubble of what we do is basically the on-site generation, the storage, still connected to the grid, but the ability to generate a large amount of on-site renewable energy generation, either through the traditional solar panels or wind turbines, or through power generation centers that will run on 100% green fuels as those green fuels come to market. And they could be biogas based, they could be green hydrogen based, but there's a lot of work going on in the background for a whole new green fuel supply, whereby that fuel is truly zero carbon, which means we can run our data centers zero carbon, and we can also benefit the community through waste heat export and also grid support as well, in terms of grid stabilization, in terms of demand side reduction as well. So next slide, please, Ian. So if we go straight to, I think probably this one describes where we're going. I think on the left-hand side, we've got the traditional connection with the grid, so a data center backed up by diesel generators, and on the right-hand side, the concept I've just described, where we may or may not be connected to the grid, but we have all our green, high availability power and cooling generated on the site, together with renewable energy being generated there and thermal storage, which feeds the data center and incorporates waste heat export. So I think I'll stop there. We've kind of rushed it towards the end, but you can see which way the industry has to go to actually hit true carbon neutrality.
Here we are. We have some questions. So let's start with Lubo, since he raised his hands, and then we can pick up the rest of them from the chat. Lubo?
Yeah, thank you. Yes, Lubo Jankovic, I'm from the University of Hertfordshire, and also from, immediate past president of ASHRAE, London chapter. It seems to me that possibilities for technological development are enormous here. And it so happens that I was approached on Monday by a group of investors into a kind of who look after a pension fund, and they asked me what are the key things about developing and investing into data centers. And I told them, I'm going to attend this meeting, and perhaps put them in contact with people who might be interested. So is that something that you guys from READ are interested in? Is there a scope for investment, or could you suggest somebody who would be kind of looking into technological development and need investment? I'm just a middle guy here. I'm not. Don't shoot the messenger.
Well, I think it's a pretty good question, because there are two reasons to invest. One is to get a good rate of return on investment, and the second, obviously, to invest in truly green technologies. So something where you really are committing yourself to climate change as well. So there are two investment streams. One is in the data center itself, and one is in the zero carbon energy center that provides that zero carbon energy and zero water to the data center. So what we do is we provide the technical advice to feed into ENGIE, our parent company, and ENGIE will normally co-invest themselves with other parties, such as pension funds, so that it's a joint venture in terms of investing in those concessions, which will normally be 15-20-year concessions with the possibility to buy out earlier. So very much the answer is yes.
So who should I point these guys towards then?
You can point them towards me and Ian.
Okay. Will do.
He
Thank
said
you.
Ian,
Good.
damn. I thought you were just going to take that, Phil. No, I'd like to chip in on that. I could guarantee you now, a lot of us will have standard pensions, and if you actually go into the detail of your pension fund, your standard life, your standard mutual, your PRU, whatever your pension is, I can almost guarantee your pension already includes portions of data center buildings. If you dig into the codes of your pension, you'll find that they are quite often linked to an AXA portfolio. That AXA portfolio will own a trading estate. That trading estate will have a big box. You'll find that you've already invested in data centers, whether you like it or not. And it's very key. I have a personal ambition on this. For people to understand their pensions and to understand where their money currently is, so that it's invested in what you want it to be invested in. And I'm not talking about financial returns here. I'm talking about ethics. I don't want my money forcing oil out of the ground in Arizona. I'd like it to be doing something much nicer. So I'd encourage anyone to have a look in your pension funds and see what shares you actually have. You probably got Amazon, you probably got Apple, you probably got Microsoft somewhere in those mixes. It's good to understand that and then see how close we are as a society and how integrated data centers really are with everything that we do.
There's a couple of other questions. Filippo,
so Professor Marou has a question about how about the other European countries? Are they integrated into the community? What country is leading the initiative?
So I can tell you that the UK is not leading. And I would say probably the leading countries, France is very much one of the leading countries, and Scandinavia as well. They are very much, I mean, they've been in Scandinavia, they've been investing in zero carbon networks for a long, or low carbon district heating and cooling schemes and waste heat schemes for a long time. So I would say France and Scandinavia. And Germany is very much ahead as well.
Thank you.
That's where we design most of our data centers. So in Europe.
The other question regarding about connections, where do you build these? That's a really good question. And you mentioned nuclear power. And just yesterday, I was sitting down with my colleagues from a sister company, Tractable, which is part of, which we're actually part of now, who are working on SMRs, so small modular reactors. Which are coming to market and will be much more a copy and paste than standard nuclear power stations. The only problem at the moment is the time to market. So data centers are a very fast build, typically 9 months from once you get planning permission to finishing the completion, whereas even a small modular reactor is about 8.5 years to market. So at the moment, the delivery times don't match up. But I think it's worth keeping our eyes on this, because small modular reactors will provide the power outputs that larger data centers will be using. So that's something definitely to keep our eyes on. And what about the availability of fiber connections? Yes, what is crucial is land in the right place, it's power, and it's fiber connections. So those are the three principal points you need to look at when you're looking to build a data center.
I don't think I'm breaking any NDAs here, but a good decade and a half ago, we actually did a feasibility study for parking a decommissioned French naval vessel in a port. I'm not going to mention which port because it had a nuclear reactor, and we were going to use that as the power for a data center. The deal was that the French Navy were actually going to run it and maintain it, so there was no sovereignty problems with the nuclear power. But that was how early we've been looking at having power supplies for data centers. It was a long time ago.
Yeah, thank you. So my question was a little bit around, I think in London, for example, you got the data centers and you got the power, and so hub is the capital, right? And then in the north, for example, in Sellafield, there's a nuclear power plant that they are trying to build, but not necessarily the fiber. So I was trying to understand which one is easier, bring fiber to power or power to fiber.
It's a tug of war. It's an arm wrestle, in all honesty.
I think where it's going is that we'll be bringing power to the fiber because the whole point of decentralized energy, decentralized generation and low carbon generation is to actually come off grid.
Thank you. So we have one question from Keith. I suppose it goes about the cooling technologies. So probably closer to Ian, this one.
No, absolutely. Why not use an open room and just use natural ventilation and fans? We've done that, and we do that in very many places. It's a lot more advanced than that. It's highly controlled, but chillerless is what they call it. Chillerless technology has been around for a while. We've been using it. We even did but there has been an experiment done with effectively servers in tents in a desert. And they ran remarkably well. And there was a very long study on that. And yeah, it's like absolutely what we try and recommend anywhere we can. Not using chillers and not using refrigerants creates a much more sustainable DC environment.
Thank you, Ian. Any last question? I don't see any movement. Cool. Okay. Thank you, Ian. Thank you, Phil, for this presentation. I hope people learn more about this industry, and we're expecting to see a lot more in the future and how it's going to evolve. Sazi, do you want to have one last word as our president?
Not last word, but I just want to say thank you. Thank you to both Phil and Ian for their wonderful presentation. I think they had tried to digest so much into an hour. There's a lot of meat in there. But yeah, thank you so much for your time and presentation.
Great, thank you for having us.
And thank you for attending.
Quite all right. Thanks for having us.
Thank you very
It's our
much.
pleasure.
Thank you very much. Thank you.
Have a nice evening.
Thanks all,
Thank
and you too.
Thank you.
Bye-bye.
Bye-bye.